Hello, we're going to spend some time talking about solving a first order linear differential equation. The first order linear differential equation we're hoping to solve is this one here. dy on dx equals 2x times e to the minus x squared plus x times y. We can see that this is a linear equation because x is the independent variable and y is the function of x. Y only appears here and here. Over here, it appears just by itself to the power of 1 multiplied by a function of x only. And over here, we've got dy on dx, the first derivative of y, nothing else going on there. So this is a linear differential equation. It's also an initial value problem. We're asked not just to find a solution of this equation, but find a solution so that when x is equal to 0, y is equal to pi. It turns out that the way to do this is with the integrating factor method. This is a method that you can always use when you're given a first order ordinary differential equation that is linear. So let's spend some time recalling what the integrating factor method is. Well, in order to apply the integrating factor method, first you have to write your ODE in standard form. So in this case, this is this down here. dy on dx plus some function of x times y equals some function of x. The key crucial observation about these particular equations is that you can multiply the entire equation by a function I of x, so that if you choose I of x correctly, you can integrate the left-hand side using the product rule, and you find that the left-hand side is equal to the derivative of I multiplied by y on dx, and the right-hand side is just q of x multiplied by I. This works provided you choose your I, your integrating factor I, to be something very specific. It needs to be the exponential of the integral of p, where p is the coefficient of the y component. So let's see if we can apply the integrating factor method to this particular equation. dy on dx equals 2x e to the minus x squared plus xy. Well, in order to do this, I have to first put my equation into standard form. Standard form basically just means that this term needs to be put on the left-hand side. So then, in standard form, this becomes dy on dx minus x times y is equal to 2x times e to the minus x squared. So the equation we were dealing with was up here. All we're doing is rearranging. This stays here. This goes over the other side. All right, now what? Well, to use the integrating factor method, I have to first construct the integrating factor. Remember, the integrating factor over here, we said this is the exponential of the integral of the coefficient of y. So that means it's going to be the exponential of the integral of this thing over here, which is minus x dx. Well, this is something that we should be able to evaluate. I know what the integral of minus x is. It's minus x squared divided by 2. So this becomes x of minus x squared on 2. It turns out that at this stage, we don't need to worry about the plus c. Do we need the plus c? No, we don't. If we include the plus c, we just get another integrating factor. But we only need one integrating factor to get this method to work. Okay, now that we've found the integrating factor, our theory of the integrating factor method that we discussed over here tells us that we can write this equation as follows. D on dx of y times my integrating factor, and my integrating factor, which I found over here, e to the minus x squared on 2. And this is going to be equal to this right-hand side over here multiplied by this same integrating factor. So it's going to be 2x e to the minus x squared on 2 multiplied by my integrating factor. Got that wrong. The original right-hand side was 2x times e to the minus x squared, and we multiplied by my integrating factor, which is minus e to the minus x squared on 2. But of course, we can simplify this a tiny bit. 2x times e to the minus 3x squared divided by 2. All right, so d on dx of this thing is equal to this thing, which is a function of x. What I'm simply going to do now is integrate both sides with respect to x. If I integrate a derivative, that just becomes the original function itself by the fundamental theorem of calculus, and then I have to integrate that, the integral of 2x times e to the minus 3x squared divided by 2. Well, how can I do this particular integral? 2x e to the minus 3x squared on 2. The other key concept I need for this question is the method of integration by substitution. If I'm integrating something and that happens to look like a function of another function, f of u, and it's also multiplied by the derivative of u, then that's just going to be the same as the integral of fu du. So that's useful because e to the minus 3x squared on 2, I can think about that as a function of x squared, and that's great because x squared has a derivative, 2x, and that's precisely what I've got over here. So if I use u, the substitution u is equal to x squared, I find that du is equal to 2x times dx. And so what that means is that this integral here, the 2x times dx just becomes du, and what I'm left with is e to the minus 3x squared on 2. But remember, I'm saying that x squared is equal to u. So that just becomes e to the minus 3u divided by 2. All right, this is something I know how to integrate. The integral of the exponential is just the exponential, but since there's a minus 3/2 here, that means I somehow need to accommodate that when I do my integral. So that minus 3/2 comes out the front, except inverted. E to the minus 3u on 2. This time I do need my plus c constant of integration. And then finally, I can undo the change of variables, replace all of the u's with x squared, minus 3x squared on 2 plus c. So this basically tells me what the general solution of the equation is. Y times something has to be equal to this. Okay, well, I'm a bit far from being done because remember, the point of this question wasn't just to solve this equation, but to solve the equation subject to that initial condition. This is where when it comes time to work out what this plus c is. The condition I have is that y of 0 is equal to pi. So when x is equal to 0, y ought to be equal to pi. So let's substitute x is equal to 0 into this equation here. When x is 0, this exponential term just becomes 1. And y of 0 we've said is pi. So we get pi is equal to this when x is equal to 0. Well, when x is equal to 0, the exponential becomes 1. So I get minus 2/3 plus that constant c. But this tells me precisely what this constant c needs to be. This tells me that c must be equal to pi plus 2/3. So now I know what my constant of integration is. My constant of integration is equal to pi plus 2/3. So now all I need to do is rearrange for y. At the moment, the left-hand side is e to the power of minus x squared on 2 times y. I'll simply multiply both sides of this equation by e to the x squared on 2. And what I end up with is this as my final solution. Y of x is equal to minus 2/3 e to the minus 3x squared on 2 times e to the x squared on 2, which just becomes e to the minus x squared, plus c, which I said was pi plus 2/3 multiplied by e to the x squared on 2. So this is how you can use the integrating factor method in order to solve a first order linear ordinary differential equation.